Good morning, one and all physics students, and welcome to another episode of Physics. It's Mr. Finn coming at you from neighborly Northville. Today, guys, we have a special treat. Today, we're going to learn one of the great secrets of the universe, without doubt, electromagnetic induction. What is that, Mr. Finn? Electromagnetic induction. That's a big phrase. So what does it really mean? Well, I'm going to show you a little video. Actually, I have a link on there so you can view it on a separate tab. But this little animated video is going to describe what exactly Hans Christian Ørsted and Michael Faraday discovered way back in the day about the fact that magnets that are moving through coils of wire can produce electric current. Pretty crazy. No motors. This is just a moving magnet running through a loop of wire, creating an electric current, seemingly out of nowhere. You may be asking yourself, Mr. Finn, is that possible? Aren't we getting free energy? Well, not exactly. There is a catch. You see, the moving magnet has to have a source of movement. So we either have to move it, imagine yourself taking a magnetic bar and just kind of plunging it into a coil of wire, almost like you're plunging a toilet. If you plunge it into the wire, you are putting the effort in to move the magnet. Yeah, it doesn't seem very efficient. And yet, it is efficient. And we wouldn't be able to have motors. We wouldn't be able to have generators. We wouldn't be able to have any of the AC power that we know of without electromagnetic induction. So, the world that we live in simply would not be possible without this amazing discovery. So let's look at it a little bit more in detail and figure out where we're going from here. Don't forget, at the bottom of this day, I have a link to a video that shows you an animated version of this exact thing. And since I don't have the supplies necessary to do that, I'll be sending you to that quick video for the demonstration. But let me walk you through the law. Okay, guys. We're just going to take a moment to try to make a very, very seemingly difficult concept to production of electricity simply by moving a magnet around into a very simple idea. Now, this is where a lot of students sometimes get a little confused. So make sure you get a chance to review the relationships we're talking about today. Michael Faraday discovered that the induced voltage, that means the voltage that shows up in this voltmeter that's attached to this coil of wire, that's induced voltage, means it came from somewhere else, is proportional to the number of loops and the rate of the change of the movement within those loops. Now, if you want to get really technical, that's due to something called flux. But we're not going to talk about flux today. It's just a little bit more detailed. What we really need to know is the basics. And the basics are this. If the number of loops doubles, that means if I have, instead of 10 coils, what if I had 20 coils? That would be a doubling of my number of loops. Well, that means that my voltage, if I originally measured 2 volts by moving this magnet in and out, if I double the number of loops, I could read 4 volts, double the voltage. What if you had 4 times the loops and the same rate of movement of the magnet? Well, then 4 times the voltage. So instead of 2 volts, 8 volts. Secondly, if the rate of the movement is doubled, this means how quickly the magnet is moving within the loops. Now guys, here is a key. The magnet must be moving. If you simply put the magnet in the loop and you leave it there, nothing's going to happen. Then your only voltage reading will happen as when the magnet is moving in. Once it stops moving, the voltage stops, unfortunately. So we have to actually keep the magnet moving. But the rate of that movement, so how quickly we move it, also has an effect on voltage. Thank you, Michael Faraday. Brilliant. If the rate of the movement doubles, then the voltage doubles. What if, you're asking, I know you're asking this because I can hear you thinking, Mr. Finn, what would happen if you doubled the rate of movement and you doubled the loops? Would that be a 4 times effect on the voltage? The answer is yes. Yes, it would. because you'd be doubling the product. Remember, it's the product. Product, right there. The product of the two. So the rate of movement of the loop of the magnet and the number of loops that it's moving into, both factors are equally important. One is not more important than the other. But sometimes it's easier to change one of those factors than the other. Tomorrow I'll be showing you the idea of a motor. I actually had a motor delivered. I picked it up from Farmington High School yesterday, so we should be all set for that. But for now, guys, let's just get the idea of Faraday's law, an amazing discovery. And that is that if we move a magnet within a loop of wire, we're going to create, out of thin air, electric charge that we could use. We could use that to power light bulbs, appliances, whatever we want. Yeah, I know, pretty incredible. Anyway, guys, I have that attached video on the Google Doc. Make sure you view that. And then tomorrow, tune in for another application. We'll get the motor started. This section is not very long, but it can be a little confusing. We're going to try to keep it simple for you guys. Make sure you get a chance to practice those homework problems. And we'll wrap up right now. Okay, guys, to wrap up, in the previous unit on magnetism, we learned that if you moved a current through a wire, you created a magnetic field. Even if you just moved a single charge, all moving charges have their own magnetic field surrounding them. And now we know that a moving magnet can create moving electric charge. So I wonder if we could use both of those things together. Actually, we do. And we send those electromagnetic waves through the air. But we'll talk more about that later in the week. For today, guys, make sure you get a chance to look over the first couple sections of that chapter. And make sure you're familiar with Faraday's law, the fact that moving magnets can produce electric charge. And the voltage will be proportional to how fast you move the magnet and the number of loops that you have in the coil. Okay, guys, you're doing a great job. I really appreciate everybody and their efforts to keep up. Shout out to all my improved kids. I'm going to do a little bit of that later this week. But keep it up, guys, and we'll talk soon on our Google Meets. So have a great day.